Hello everyone, I am Theodora and I'll be here as tech support during the tutorial. I want to introduce you to our tutor, Rigerta Demiri. She is a senior data engineer at GitLab and she will hold the Getting Started with Containers and Kubernetes beginners workshop. Enjoy.
Hi, everybody. I can see that a lot of you are already here. I'm very happy to see so many joining. I would wait at least a minute or two if anyone decides to join right now or will be joining in these last minute, seconds, and then we will start. Okay, so I have started sharing my screen. I hope you can all see it. Someone maybe can confirm that you can see it, and I will also go into presentation mode. I don't know how we will do it to communicate during this presentation. Thank you very much. Yeah, using the chat is great actually, because I would like this to be a bit more interactive. And from the way I see it is that I don't even see you. So generally I don't see the audience and I don't see you on camera or not. It would have been great if I could, but it is totally fine. We will continue with what we have. So it's already 11:47. I say we start now. I'm very happy that you have all joined. This is the Containers and Kubernetes workshop for beginners, meaning that you have heard about containers, you have heard about Docker, you have heard about Kubernetes, but probably you haven't really worked a lot with it. Otherwise, if you have, this will be too easy for you and you will not be able to get a lot of value. But I'm hoping that most of you will learn at least a thing or two. I'm Rigerta. I'm your host or your workshop host for today. And I wanted to make a quick disclaimer. This presentation that I'm talking to you, that I will present to you today, has been a collaboration between me and Katarina Sik. She's a very close friend of mine and a previous colleague, but she could not join us today. So I will present the second part of the workshop, the Kubernetes part that she prepared for you too, with her permission. But if you do not know her yet, I think you should check out her GitHub account. She also has a LinkedIn account where she posts from time to time, and she has started talking recently. And she's a Kubernetes representative in Vienna. She's super cool. That said, about today, what will we do today? Today, we are going to learn a bit about containers and Docker. What are they? Why are containers so cool? Why do we hear about them all the time, everywhere in IT now? How to create and how to use them. We will also learn a bit about Kubernetes. What is it? Why do so many companies use it? Do all of these companies really need it? And how do you get started if you want to try something new with Kubernetes? We will, of course, have some demos and then some troubleshooting and questions. I would like you to ask questions whenever you have them. So you don't really need to wait for the end of the presentation or when I reach the part where I ask you if you have any questions. You can just ask anytime. I will try to monitor the chat. I hope I will also, we are two here, so I will get some help, I hope. And we will not leave your questions unanswered. Okay, also if I'm talking too fast, please let me know. I can slow down a little. Otherwise, there is not a lot else to say. I'm Rigerta. I'm a senior data engineer at GitLab. I organize a Vienna data engineering meetup because I'm based in Vienna. And on my LinkedIn, you can feel free to just connect with me, send me a message, complain about this workshop in the end, maybe send me some feedback if you feel like it. And here in the bottom of this page, I have also linked some organizations that are very important to me. I used to volunteer a lot with Coder Dojo in Vienna, teaching kids how to program. I'm an amateur CrossFitter. I used to volunteer with female coders as well to teach women how to program, the ones who are interested to get into the field. I'm a Red Cross volunteer, and I also hike and organize hikes with Alpenverein, the Alpine Club in Vienna. Cool. Let's get straight into the subject of today. So what is Docker? Docker is an open source tool that you can use to turn any application that you have written into a container. This container can then be deployed in any system. Basically, you are packaging an application that you write. But what is an application? Any kind of piece, any piece of software, anything you write. If you write, for example, in university courses, we started out by writing, I don't know, a calculator, or a simple program that prints something, a hello world program, anything, even that minimal example would be an application. Applications are usually written in specific programming languages, I don't know, Java, Python, C#, C++, anything that you can think of, and typically have one or more dependencies. For example, a Python application would be depending on many Python libraries. A Python application that does data science visualizations, for example, would need a library that creates charts, a library like NumPy to perform mathematical operations and so on. And they would all be dependencies for our application, meaning that before our application is able to even execute, we would need to have them loaded into the system. Which GitHub link? And you don't see the presentation screen, that's not great. Just a second. I will share it again. Can you see the presentation screen now? Yeah, thank you very much, Vladimir. Thank you. Very nice. Thanks, everybody. I will also share with you, actually, I hosted all of the scripts and all the demos on GitLab on my personal account. And this is public for everybody to see. So the code I will share with all of you. If you want to, I can share it right now, but it's a bit too soon, I think, to get distracted with it. But as soon as we get into the demo parts, of course, I will share everything with you. So the presentation, PDF, and the link to all the code and everything that I will talk about today. So no need to worry about it, no need to take notes. Everything will be shared with you. Cool, so I was talking about applications and how they are written in different programming languages and how they have dependencies and so on. And now we want to talk about containers. So what is a container? A container it's a bit funny to say that it's a self-contained, runnable software application or service. If you write an application, as we said before, for example, a calculator application, and you are able to containerize it, so to build a Docker image that has all of the details of your application, so the dependencies definition, the code for your application, and everything else that you can think of that makes this program possible to run, able to run, this is what a container is. That's why the word self-contained, that's why the word container as well. How do we do this with Docker? How do we build a container with Docker? What we generally do is we write a Docker file. A Docker file is nothing more than just a file that has a specific ending or specific type. So basically, you just write Docker file with capital D exactly as it is written here, and this is a keyword. And in this Docker file, you will write all of the details, everything that you need for your application to be able to run. So all different commands, let's say. You can think of it as a recipe for cooking something where in every line you have defined step by step what to do so that your application will run. Do we have any questions so far? And if not, I will continue. Key concepts regarding Docker and Docker containers. An application, which we just explained what it is, dependencies, application dependencies. So all of the software libraries one application needs to be able to run, to be executable. A Docker file, that is a text file containing a set of instructions or a recipe for our Docker image. A Docker image itself. This is a bit tricky to understand as a concept, but once you write a Docker file, you have the definition for what your Docker image will be. So whatever you write in a Docker file will be what will be built as a Docker image. When you run your Docker image, then you have a container. So basically from a Docker file where we only have the recipe, we build a Docker image, which is in the recipe analogy, this would be like if you're preparing a cake, the Docker file is the recipe that tells you how to mix all the ingredients together. The Docker image would be, this is not 100% accurate, but just to give you an idea, the Docker image then would be the mixed batter, all of the things that you've mixed together to make apple pie. And when you run it, it's when you bake it, and then you have the container in the end. That's a bit of a funny analogy in my head, but it works for the example. A Docker container basically is a running instance of our Docker image. We create a Docker container when we run Docker run, the command Docker run. And from the same Docker image, you can run multiple containers because the image is basically a blueprint that has all of the container creation instructions. You can call it 1,000,000 times. It doesn't really matter. You have no limits. You could do this, for example, to have multiple web servers. Your image, your application would be a web server that accepts HTTP requests, for example, and returns a message to the user. And you might want multiple servers to be up and running because you might want different requests to be sent to different web servers, and you want to enable load balancing and so on. This is also a bit more advanced, and we will talk about it on how Kubernetes helps a lot with exactly this notion of load balancing. Docker registry is also a very important notion or concept. All of our Docker images are stored in a Docker registry. It can be the public Docker hub that anyone can access, even without an account, so even without registering yourself. But it can also be a private Docker registry. So many, if most companies, private companies, have their own Docker registry, which is basically once they have these Docker files stored in a Git repository, they will not only store the code from the Docker files, but once they build the images, they will send them to a Docker registry that stores images only. These images can then be loaded, of course, on your local machine and can be run to create containers. As I said, the Docker Hub is the most famous and actually the official public Docker registry that anyone can access. Cool. So now that we have some of the concepts explained, let's take a tiny step back. Why do we even need Docker? So why was this necessary for this technology to be created? How were applications deployed before we even knew about Docker, before we had it? What used to happen was that a developer would develop in their workstation, a whole team would develop in their different laptops, computers, whatever, and then they would push their code let's say in this example, for 3 applications into 3 different repositories. So application 1, application 2, application 3. And then from the development environments, you want this to be published to the real world. So you want these applications to be deployed. That's what we call publishing a web server or website, for example, that would be deploying a website. And how this used to be done before Docker is that you take all of the code of the applications, whatever was part of the code, and we would get a list. This was purely a notepad text file where a human would read steps what to do. So if I was a developer and I developed a certain application, I would tell the person that would deploy it, first enable this on your machine, on the server where you're deploying, then enable that, then make sure to copy all of this code into a specific folder in the server where we are deploying, and so on. So there are lots of instructions that come with the deployment instructions. A different developer, generally the one that takes care of infrastructure and deployment, would take care of installing and configuring all of the necessary libraries, dependencies for all of these applications in the production server manually. This was a widely manual process. In the end, if this all went well, the user would be able then to access these 3 websites basically from their browser, from their laptop, using the browser. What is the problem with that? So one of the major problems was that there was one production server. Most companies would use the same server to load there, to deploy their many of their applications, different applications. But this is not only an error-prone process because it would happen manually, but different applications might also need different software and software versions, different libraries and different library versions. So basically, if we are deploying 3 different applications on the same server, each of them might need a different version of Python, for example, or a different version of NumPy, another Python library, or whatever. It doesn't really matter. And whoever had to work with Python dependencies knows that this can be quite a hassle. So that's absolutely not fun. Of course, there are dependency managers like Poetry, for example, PyEnv, etc. So there are plenty of using different environments to deploy this and so on, but that adds to the complexity. All of this causes dependency issues, as we said, and of course, a very painful deployment process. More problems that come with the old way of deploying have been memory and processing power over production server, which are limited. These 3 applications that we said that we would deploy on the production server, they all have different memory and processing power needs. Some of them are more memory. They need to process more, to use more memory. Some of them need to use more CPUs and so on. But the server itself is one and it's limited. I mean, you can add memory and CPUs to a server, but I mean, you don't want to have to endlessly scale this server and make this a giant machine. It's also not, it's not going to last forever because, I mean, this is not the solution. You want to make an efficient, to create an efficient way of deploying. You don't want to endlessly have to just add resources, basically. This is also very important. This is a part where Kubernetes and Docker play very well together, because with Kubernetes, as we will see later on, you can actually configure resources. So how much memory and how much processing power each application is allowed to use. So minimum and maximum, etc. So it makes managing of the server memory and CPUs much, much easier. Okay. Once we discussed what the problems have been with Docker, then with the non-existence of Docker, let's say, or with the old way of deploying applications, we can talk about the benefits of when Docker entered the system. What Docker basically does, before I go to the benefits, I would like to explain these two images on the left that I took from the official documentation of Docker. Instead of virtualizing the OS kernel, the operating system kernel of the machine, let's say in this case, the production server, and the application layer of the operating system, for Docker, using Docker, we only virtualize the application layer of the operating system, and the kernel is the same. So it is not virtualized. As you see here, we have a separate infrastructure layer for virtual machine virtualization, the old way of virtualization, and here we have two. We have infrastructure and host operating system that basically, by default, would have been Linux. So Docker runs natively on Linux, and it needs an extra step for Windows. WSL2, probably you have heard of it. There is an extra step that you need to enable on Windows if you're trying to run Linux containers. There are, of course, Windows containers as well, but they are a bit less spread because they have, I don't want to say less adaptable, but they are not less adaptable, but there are less, there's less support for all of the other libraries, all of the other software that we use with containers. So mostly, or the most used containers usually are in Linux machines, or they derive from Linux machines. Cool, so what are the benefits we're getting with this architecture now? We get isolation, so there's zero conflicting with the host system. We do not touch, we do not interact with it. The packaged application, our application, and all of its dependencies, code, libraries, system binaries, everything, they are all in one place. So basically, if you take a container, it is self-sustainable and it is possible to run it without needing anything else. So you can inject it anywhere on any system that is running Docker. And this is the only dependency. You need Docker, but you do not need anything else because the container will take care of installing everything that it needs. This also gets rid of the very, very common and famous problem of it works on my machine, because every developer had a different system locally. So I had Python 3.10, somebody else had Python 3.7, and an application would not work on both of them. If the application actually needed Python 3.10, it could be that it wouldn't work with Python 3.7. With Docker, if I only get a Docker file, I will make sure that once I run this image and I create a Docker container from it, I will install the Python that I need there. So I don't really even care, I don't mind what is the operating system Python, because I'm doing this on a separate layer. I'm doing this inside the container, which is basically using the infrastructure of the host, of the computer, server, laptop, wherever I'm running Docker, the hardware from it, but it is using software that it installs itself. It's using software that you have instructed to be used in the Docker file. I hope this has been understandable so far. I know these are a bit of complex terms, abstractions to explain. So please let me know if you have any questions. I am all the time monitoring the chat and trying not to go too fast. Otherwise, I would just proceed to the next step. So I really hope that this has been clear, that we get isolation with Docker, we get a fully packaged application, and we can always rely on the fact that this will run fine, no matter what the hosting system is, because you do not rely on anything that is installed on the host system. You will actually install everything based on the Docker file. So everything will be installed once the container is running. Extra benefits that we get by using Docker. Thank you, Darko, that's very good. Extra benefits that we get by using Docker are better resource consumption management, and I will share this with you in the end, so you will have access to all of the links. But this is just a link on the official documentation on resource constraints for Docker. And efficiency, of course, because these packaged applications via Docker, they are very, very lightweight. It does not cost a lot of memory or CPU for your machine to actually run a Docker container. Of course, it depends. It depends on how big the Docker image will be. It depends on how you built it. If you made use of several advanced concepts, like using layering with your Docker images, because every layer is then cached. So you don't need to reload everything from scratch and so on. There are multiple ways you can make your Docker images efficient, but that's a subject for another time. And as we said, you can run many Docker containers on a single production server without killing the server, basically. Cool. I am at the end of the short talk before I get into the demos. If you have any questions, I would be happy to answer. Otherwise, I would get slowly into a step-by-step Docker introduction. We'll check out the Docker registry. We will use existing Docker images, run them, try to do some stuff with them, and then we will create our own Docker image, basically from a simple application I have created, and I will share with you. Meanwhile, I think I'm also going to send in the chat the link to the documentation. So basically to the materials for all of this presentation. I have here all of the code for the demos that we will discuss today, so you can just copy paste if you want to follow along. I would love it if you follow along. Even if you have issues, we can discuss them together on the chat. Initially, I actually planned this workshop as a very hands-on workshop where we all installed Docker together, install kube control later and so on, and then we try these commands. But let's see how it goes. So what in the link that I shared, the part that you or that I will go through right now is the Docker first steps. So you can just open the shell file, and I will open the same, and I will go through the demo. In order for those commands to work, you will need Docker to be running locally. Instructions on how to run Docker, I will just share this link with you, are here. I am on a Mac machine, and I'm using a Rancher because that is my personal preference. So I use Rancher desktop. This is open source and for free for anyone to use. Maybe you want to use it, maybe not. It's your choice, because there are, of course, other existing solutions for Docker desktop for Mac, Windows, and Linux, and other distributions. You can choose whatever you want. I think the problem with Docker desktop has become that for large companies that use it commercially, I think you need a license as of a certain number of users. But if you just use it for yourself for development purposes, it should be totally fine. You will also need an IDE or any text editor to use for editing files. I prefer Visual Studio Code, and this is the download link for Visual Studio Code. Opala. This is not it. This is what I use. You don't have to, but if you want to, you can. Otherwise, you can use an editor of your choice. And then you might need, but this is again not a requirement, a free Docker account in the Docker registry. So hub.docker.com. It's the Docker Hub, the public one that I mentioned before. You do not see the links in the chat that I'm sharing with everybody. That's not great, and I wonder why. Okay, I think I just need to send it to everybody. Okay, now you should see them. Thank you very much. Excellent. And this is the last one for the Docker Hub. Here you can create an account, of course, so you can sign in, you can sign up, depending on if you have an account, but you don't really need to, because most of the So you need to create an account either with Google or whatever, however you prefer to. But what the images we will need, for example, Nginx, which is a web server, they are public. So we do not need to worry too much about it. So we can just use these images as they are. These are all the prerequisites. I don't know if somebody wants to follow along and has the problem. If so, please text me in the chat and I will take a look. Otherwise, I will just basically continue. Okay, then I will continue because nobody's asking any questions, or at least I don't see any. Any raised hands? Excellent. Okay, let's continue with the demo. I will now try to share my Visual Studio Code. Can you please confirm that you see the code? So you see Visual Studio now? Just need somebody. Excellent. Thank you. What will we do? We will start very, very easy. I am in the Docker Workshop app folder, and I will go to the, this is wrong. I am in the Docker First Steps folder, and I will go to the docker.shell. I just wrote the shell file for all of this, but it's not really, you don't execute all of it. It could be a not text file. As we said, Docker Hub, so hub.docker.com is the largest public Docker registry that has pre-existing images. Somebody has built images of any application that you can think of. So whatever you can think of, I think exists on Docker Hub. So somebody has made an image of SQL Server, for example. Maybe some of you use SQL Server as a database, or could I use a light theme? Oh, that is cool. I would like to, if I know how to change it. Theme, light. Is this better? Excellent. I hope it's better. I don't know what else to change. You're welcome. Okay. Yeah, I wanted to say, yes, we were here so that the Docker Hub is the public hub for any kind of images. I don't know what kind of applications you use daily, but as I was saying, for example, PostgreSQL, somebody has made an image for it. SQL Server, another database, somebody has made an image for it. Python, of any version, somebody has made an image for it. And I don't know who writes these images, because sometimes it's just a person that decides to, any developer, any one of us could do this and then just push it into Docker Hub. But I think you need approval for it. I'm not entirely sure, because this can, of course, break the image. So the point is that whenever you push and you update and you tag, you need to be sure that this will not break the image and people can use it. So this image, for example, the Python Docker official image for Python. What does it mean? It means that it's a Docker file that has the definition of how to build an image that has Python installed in it. Somewhere we should be able to see exactly what is the Docker file for this. So it starts from Python 3. It sets the work directory to user source app, etc. Does a lot of stuff. And this is how you can use this image. So basically you would, the only thing that you need to do in your Docker file, this would be a Docker file for your application. You just need to say from Python 3. So from this image that exists here publicly. And then you can continue. And then you, in order to know what this image has inside, we should be able to find somewhere the definition. So let me just check any tag. I could just take any tag actually and see what they have done. These are all of the layers that are built via the Docker file. And what am I trying to do is find the actual Docker file for it, definition basically. Let's see. This is the latest tag. The code is in GitHub, okay. From scratch, this is one of the images, and then let's see. Automatically created Docker files. Okay, Python latest official image viewing GitHub. What does it do for us? Let's see, somewhere it should just install Python. Setting the environment, variables for Python. Lots of work. It's getting Python as a zipped file, and then it will install it for us. It will set all the home variables and so on. So the image will be already coming with Python installed for us. idle3, pip3, pydoc3, python3, python3 config, all of them. Excellent. In our case, we don't care about this at the moment because we don't want a Python image, but this was just to show you that multiple images exist on Docker Hub. Anything you can think of, it will be there. Private Docker registries, for example, AWS hosts its own or has its own feature for any company that uses AWS to host their images on ECR, Elastic, I think, container registry. Google has a container registry. Private companies also host their own because, of course, not everybody wants the code for their images to be available online, and not every company is open source. How does a private Docker registry, what's the difference between that and the public one? That the private one actually requires authentication, so you cannot access them without. We can start with a bit of running some Docker commands. We can check what do I have on my machine, but actually I have a lot. So Docker images is what I wanted to show. I have a lot of stuff because I use Docker daily for work. So I have a data science image I've built myself. These are all whatever comes with by default with a Rancher installation, which is a distribution I use for Docker because it's open source free one. I have an Nginx, so web server installed where I've been testing stuff, another Nginx. And you see, I have Nginx is exactly the same name, and what is different for them is just the tag. So one Nginx is version 125.3, and the other one is 123.4, and so on. I can have as many of them as I want in my machine. So basically, I can test out different features of different versions of Nginx, and all of them in one computer that is just running Docker, basically. Let's see if I have any running containers. So Docker PS. Usually I clear, just for you to not be surprised, I clear the command line before I run any other commands, unless we will need to know the result of the previous one, just for clarity. So Docker PS will show me running containers, and apparently I have plenty of them. Let's see what's going on here. Maybe I make it a bit smaller. Some Kubernetes default ones, some Kubernetes for work, some web server for testing an Airflow instance locally, and so on. So things that you should not have if you're running this for the first time on your machine. If you just install Docker, you should have only the default stuff. Let's see. How can we pull an image from Docker Hub? The public one. I haven't logged in. So as you saw, I was not logged in on hub.docker.com. So not signed in, not signed up, nothing. I will just go here and I will try to pull Docker pull Nginx 123. I don't know, let's see what versions do we have, because I already had 123.4, but it shouldn't be. It is not a problem for me, but I just wanted to show you one that I don't have. However, let's do this. It should say that I already have it, I guess. It is up to date. Okay, that is good. Did you notice just running a Docker pull command and then the name of whatever I wanted to pull from Docker? That's all I needed. I did not need to do a Docker authenticate or Docker login, which you normally need to do if you are pulling images from a private repo or private container registry. I just needed to say Docker pull, and then the image is basically available on my local machine. If I check Docker images, it should be the latest one. It should be here, 124.3. Did we say right? 125.3. Where is my Nginx? Here. Excellent. Now we will run it. This is a web server, meaning that when you run a web server, you will get an HTTP index page, HTML index page. As a result, the way I will run it is by just saying Docker run, and I will use the command -d for it to run in detached mode. Otherwise, what happens is that the command line will be blocked because this will run and it will give me web server logs all the time. I mean, we can try it and then I can stop it. We can say Docker run Nginx 125.3, and we will see, I have logs here, and now I cannot use the command line anymore. Although this is working fine, I would like to do things with it. I would like to work, I would like to run some other commands, and I cannot do it anymore because this is blocking for me. The web server is running all the time. So what I will do is press on my Mac, Control-C to stop this. It exited from the web server. I will clear what I had, and then I will run it in detached mode, so that this frees exactly. It just gives me an ID. I know this is running, and then I do not worry, but this freed up the command line for me. So it means that now I can check running containers, and this should show up as a running container for me. Nginx 125.3 several times, but one of them actually died because I killed it, but the second one was just created like a second ago. It has an ID, container ID. It has an image name. It's been up for 14 seconds. I started it 15 seconds ago, and then we know it runs on port 80 TCP. This is its default port, by the way. Each of these applications come with their own default port, and that is what this one has. Let's see what's the name. This has Syrian Bosniak. These are just some very random names that Docker assigns to running images, running containers, sorry. So we can check logs, Docker logs, this, opala. And we see, what do we see here? Okay, entry point D, configuration complete, ready to start up, that's good. These are just web server logs, so nothing special. But as I said, since this is a web server, in order to reach it, this is running on Docker. This is running inside a container. You can imagine the container running somewhere on my computer, but how can I reach it? How can I reach this web server? In order to be able to access it, I would actually need to expose the container port, which was the default, as you saw in the logs. It was, when I showed you, it was 80, to the host port, to my computer port that I wanted to map into. So I could map it to the same port, 8080, because the port that is running in the container is not exactly the same as the one that is running on my machine, my host machine, my laptop. I need to open or map them so that the requests can be redirected on that port. So you do this on Docker by just exposing the container port. So for example, what I did here with the port binding, I said port 80, that was the default for Nginx, map it to port 9000. I just chose 9000 for no reason, because I assumed it should be free in my machine because I am not using it. But since I've run this workshop before, maybe this will run into an error. Let's see. It did not run into an error. This is good. Let's see logs. Everything looks good here, okay. I can also map another port. That's what I wrote. Okay, so I can have multiple Nginx servers of the same version running in multiple ports and so on. Let's do this. And then we say Docker logs. Sorry, Docker PS, because I want to see the running containers, and I might have multiple now. This was the one we had before, then we created a new one, then we created a new one because they are running on multiple ports. So this was on default port, but we never exposed it to our local computer, so we cannot really access this URL. But these ones we should be able to in port 901 and 9000. So let me just go there. This is how I access the one in 0000 was the URL because it's just local. 901 and 9001, and 9000 is the second server. So if I do exactly the same, but with port 9000, this is also working. There are multiple instances. So I have 2 web servers now running on my machine as containers. It was as easy as just saying Docker run Nginx once on this port and Nginx again on the other port. If I try now to, I will just make the Visual Studio Code a bit smaller so that you can see this as well. If I try now to, let's say the one that is on 9000, let's kill it. So we can stop it. Docker PS. Let's see what was the one on 9000. This one. Cranky Lovelace. I will stop this container. I should see that this Nginx web page is down once I do that. So Docker stop this one. Okay. If I refresh here, this cannot be reached anymore. Makes sense because I stopped the Docker container, it's not running anymore. Okay, but this is still fine. This is still running. I'm refreshing here. This is still okay because this is still running. If I also stop, of course, whatever was the name of that one that is running on port 9001, Silly Faraday, this will also go down. So this one that is already running, it will go down. So stop. Takes a second. And now I refresh here and I cannot access it anymore. You see how easy it is to start and stop a web server in this case, just because I chose a web server, but it could be a Python image, it could be anything really that has an open source Docker image for it. So think of your favorite database, for example. You could spin up a PostgreSQL instance or a SQL Server instance or I don't know, whatever you use, and have it just running on your machine. The only thing you would need to do to be able to access it, let's say via browser or via or connecting to it via any tools that you use to connect to database servers, is exposing the port. For example, SQL Server has its own fixed port that now I thought I remembered, but I forgot. SQL Server TCP port. So the default TCP port for SQL Server would be 1433, which means if I was running a SQL Server image here, I would map 1433, which is its default port, to whatever port that is free on my local machine. And that is it. And then I would be able to connect to the SQL Server instance. I mean, how cool is this? I think this is pretty nice. Because then you don't need to have heavy installations on your machine. You can spin it up, run tests, do whatever you want. Of course, it is different if you want to have this productionalized in a sense, because you want to save state. And in this case, you are not saving state. So every time you spin it up and spin it down, you recreate it. Cool. So even though I have stopped these containers, this does not mean that they have been removed. They are just there. They are not alive, basically, but they are still existing. So Docker start, silly, what was it, Faraday? should start for us again the image that we had before. I don't remember now if this was the 90, but we can try. I think this was the 9,000, yeah. Yes, and it has worked. And if I try the 9001, of course it won't work because I haven't set it up yet. But if I say Docker start, what was the name of it? I think it was this one, Cranky Lovelace. So let's say start. And it should start for us. 9001, okay, excellent. So both of them are running. Running Docker PS -a or A, this will show us all of the containers, even the ones that are not running. So as you see, I have some Airflow containers here that have run the last time, like 4 months ago, and I should do some cleanup. We also have these ones that now I made them running, but even if they were not running, they would be showing up here, and so on. So when you run Docker PS, it shows you only the running containers. When you do PS -a, it will show you only it will show you all of them, even the ones that you have stopped. To remove containers entirely, maybe I copy an ID here. Let's see, for Silly Faraday, I will run a Docker remove container, Docker RM. I will write -f. I usually do this to force it to delete it so that I don't need to stress about it if some error occurs or so. Basically, I've removed the first image here. So if I run it again now, I should only see 1, 2, 3, 4 Nginxes and not 5. Let's see, Docker PSA. And I have 1, 2, 3, 4. Q&A, I see something, one question. If the application is used by millions of people and they all have different OS and app version. App version is understandable, but how to handle millions of people when they are connected to the same server? Exactly, this is a very good question. Thank you very much, Bilal. What happens is that you will need a load balancer. A load balancing means that the image that you are serving could be the same. You can, as we said before, you can run the same image 100 times, 1,000,000 times. The image only specifies what software you are serving to people. But how the infrastructure behind it and how many people hit on the same node, how do you deploy it, is your solution. This is where Kubernetes helps you a lot, because you can set up a load balancer that has a specified definition to have to deploy exactly the same, for example, Nginx image with this version on 100 servers located all over the world. And then you specify rules that whatever requests are coming from Europe, please send them to this server. Whatever requests coming from Latin America, send them to that server, and so on. What you deployed is exactly the same Docker image. The same container will run, so the definition of it is the same, but it will have multiple instances of it. As we tried here, we had the same image with Nginx, the same versions, but they are deployed multiple times, and they are running on different, in this case, on different ports on the same computer. But you can make them run on the exact same port, even on 80, for example, everywhere, but on multiple computers. You can do this. And that is how Kubernetes helps. I hope this answers your question. We will go a bit more into it as soon as we get into the Kubernetes part. Okay, I'm going to mark this as done. Feel free to let me know if you have some other concerns. Thanks. Excellent. Okay. What were we doing? We saw that we basically removed one container by just saying Docker RM, so remove container. And I usually use a -f in front of it, so just for the force, so that it is removed immediately. Cool. I think with this part we are done, and I think I should go a bit faster because we have lots of stuff to cover until 1:30. But I definitely would like us to go through this example that I have here. So I've built a very, very, very simple application in Python. This application is importing two libraries. So Streamlit, which is, if you don't know about it, is a pretty cool, very lightweight, open source library that helps you building websites very quickly. So for example, you write import Streamlit and then write some text and whatever, and then this will be an application for you. This is not so easy if you think in classical development, where you usually need a server for this, you need to deploy it and so on. But this is happening on the browser already, and it is doing most of this work for you. So that's why I chose to build a Streamlit application. Also because I love open source libraries, obviously. And what did I do in this Docker workshop app we are at now? In this application, I have a title, hi from Streamlit. I load an image. The image is also a dependency in this case for our website. And then I set a copyright for the image and so on. I want to Dockerize this. So I want this application to be a Docker image that I can deploy anywhere, meaning that even if my computer does not have Streamlit at all installed, and it doesn't have Pillow, from which I imported image, it doesn't matter, because my application, Dockerized application, will take care of this by itself. How did I do this? So I wrote the application. The application depends on these images, on these two libraries. I wrote a requirements file. This should be very common to any one of you who has been writing applications before, because usually you want to save all of these requirements or whatever libraries your application needs in a requirements file, so that via Python you can simply run pip install -r for requirements, and then the name of the requirements file. Okay, I guess, Michael, the comment you made is regarding Streamlit, right? A nice GUI. Okay, thank you. That's pretty cool as well. I just use Streamlit because I'm familiar with this one and I like it a lot. Yeah, thank you. Cool, requirements file, we have it. We only need these two ones for now. So that's all. Our application is ready. In order to run it locally, I would need to run Python. I need to get there in that directory. So let's go to Docker workshop app. And I am there. First, I need to check out master because I'm on a different branch. Git pull. Veljko, I do not know the answer to this one. I'm sorry. Somebody else should be able to answer you. But I would assume that you would get the video recording as well. I think they are going to end up on YouTube. Not entirely sure. Okay, so I'm now on Docker Workshop app. And I want to run this application. I'm actually really hoping this will fail, because then you know how Docker helps you, because this will succeed when I run it via Docker. And then I know, and I'm sure of. But from my local machine, maybe it will fail because I don't know if I have Streamlit or Pillow installed. So let's see. Python app.py. Excellent. No module name Streamlit. So it means I need to install these things locally for this to work. That's okay. Let's not do that. And let's just try to run this via Docker so that I try to make the point I'm trying to make. We write a Docker file to Dockerize our application, our simple application that consisted of app.py, images, and requirements.txt. In this Docker file, we start from Python 3.8. That was the version of Python I needed. Basically, I'm telling Docker to start on a container that is based on the Python 3.8 image. Then I say, please expose the default Streamlit port, like we did before. Streamlit default port is 8501. And then I say, change the working directory to app, where my app is. Copy all the files from the local repository where we are. So dot is it denotes a local. under app. So I have made this. This is an app file in the container that will run later. Then I copied all of the requirements there as well. Then I run upgrade pip and then install requirements. So basically in the container, we will install the requirements we need for the application. And then I will run Streamlit as an entry point for this container. So as soon as the container is up and running, it should run Streamlit. With the way you run Streamlit is just saying Streamlit run and then the name of the app. And the server port is 8501 because it's the default Streamlit port, and server address is 000 because whatever we are developing locally right now, so it doesn't really matter. Cool. So we have in mind that in my local machine, this did not work because I did not have the necessary dependencies. Let's build the image. Docker build -t. I will call it demo, and I will say with whatever I have on this local directory. So dot. It will take some time for it to build. Basically, it will load this image, it will expose this port, it will go step by step through everything. These are multiple layers that it will have, the image. With every command that it runs, it creates a new layer. That's why you should always be careful and combine these commands whenever possible so that you have as few layers as possible. This will make your Docker image smaller in size, more lightweight. This is almost done. Installing requirements now, just like we told it to. Copy requirements, run pip install, exactly what we have told it in the recipe that we have defined before. Okay, seems like this image got built. Let's see in Docker images if we have our image. It is called demo. Its version is latest. This is by default, by the way. So you can, if you want to tag it a different thing, you can. You can create multiple tags or versions of the same image, and you can play around with them. And it was 1.4 gigabytes. I'm not too happy with it. It's a bit too large, but I think most of the size comes from the source image. There are multiple types of source images. You can take a slim bust, I think. There is a slim version of Python that has a bit less libraries in it and so on. It's a bit lighter. But for now, we're good. We're good with this. We don't have any problem with it. What we want to do is run. We want to Docker run. First, I will clean the command line so that I can go up. Okay, what we want to do is Docker run in port 8501, not workshop app. I called it demo. So let's run demo. And the tag will be latest. Okay, this seems like it is running. Docker PS, the demo latest is running. Okay, let's see if we can access it on a browser window. Excellent. This says hi from Streamlit. It has this image and it has a copyright of the image. This is my website. This, if you remember, did not work on my local machine, but I have now deployed it via Docker on the same machine, on this computer, where I have no Streamlit, and it has worked. Why has it worked? Because it took a new Python image. It created a container out of it. It installed their Streamlit that was necessary and Pillow for the image loading, and then it deployed the application for me. So I hope the point that I was trying to make is made. If I want to stop this image now, we know how we do it, right? We just go and we say Docker stop this, and this shouldn't be served anymore. Docker stop. And we should see that this is not available anymore. Exactly as expected. But if I start it again, it should be, and then as usual, basically. Yeah, there are multiple ways of reducing image size. One of them would be to run as few commands as possible, for example, so to try to not create a different layer. I have created here as many layers for this image as there are commands. Another one is to use multiple, I forgot the term for it, unfortunately, I'm sorry, but you can have multiple from commands in the same, I think they are called composite images. However, you can also just, what I usually do is just try to find the best ways of reducing image size, best practices. And this is funny now because I'm Googling, but that's what I generally do on my daily life as a senior data engineer. So if anyone else does it, please do not be ashamed of it. Best practices on how to, on what did we want to say? On reducing Docker image size. There are many, many websites about this. There's lots of dev community apparently have written something about it. So many, many, many different resources that you can find. What are best practices? How can you do this and so on? Multi-stage was, sorry, that was the term I was trying to find. So when you have, first you build your image, then you go into production, this will use the cached image from here. That was what I tried to say. Avoid installing unnecessary dependencies, extra things you don't need, etc. So yeah, I can just share this link with you. That's a good documentation, but there are many, many different ways of optimizing this. Cool. Okay, so here I started it again. I think that is running, yeah, but I want to stop it because we don't need it. And I would say that with the Docker part, I am actually done. And this is demo part 2, where we created a Streamlit application, ran it locally, which did not work for us because I did not have the dependencies, which was great. And then I built a Docker image for that and it worked. I have a couple of main takeaways that I really wanted to mention, like especially that Docker is, so basically the Docker is an open source virtualization technology. With it, you can package your application into a single runnable artifact, a Docker image, like we just did together, and you saw that it ran. And Docker images will actually run everywhere, independent of the platform you deploy it to. And I think our example showed this perfectly. If you have any questions about this part of the presentation, please let me know now. I will, of course, I shared this with you already in the GitLab repository, and then you can check out all of these links. I really like Tech Word with Nana. I've also learned a lot from her, but I also read a lot of the basic documentation, official documentation. What you could do next from here, you could build a simple application in any language that you prefer and try to containerize it like we did together, play around, experiment with Docker, try to make Docker files smaller, just have fun, basically. Thank you very much. Let me know if you have any questions. Otherwise, we will continue with the next part. Okay, I think we do not have any questions for the moment. Oh, thank you very much. Okay, so I checked the Q&A and I checked the chat. There are no questions, so let's proceed. Sure, sure. Very happy to help if I'm helping at all. Kubernetes is the second part, is the part that Katarina has prepared for us and that I am presenting for in her behalf. And let's talk a bit about what Kubernetes is, why do so many companies need it, and how to get started with it. What is Kubernetes? We learned all about containers. So by now you know what containers are, how we use them, why they make our life easier. You saw by a living example how it doesn't work on my machine or it works on my machine was actually not a problem anymore for us when we containerized the application that ran then just fine. But these containers, obviously, in a real life cases, we do not have just one container and then we deploy it somewhere and that is it. That is usually just a demo case. That is something you show to people to explain how these things work. But in a real life scenario, you would have many of these containers. which are deploying different applications, which have different resource needs for CPU, for memory, which need to be deployed on multiple places, let's say even physical geographical places. Like someone of you asked about load balancing before. You cannot have millions and millions of users hitting the same server all the time, because eventually we'll run into memory or CPU problems. So of course you want to spread the load and so on. And this is where Kubernetes comes into play. Kubernetes is a container orchestration system. It takes care of all of the containers that you want to run, the infrastructure behind it. It will automate deployment, scaling, and management of your containers. Of course, based on the descriptions or definitions that you are giving it. So just like you write the Docker file to create the container, you will then write files for Kubernetes to build Kubernetes objects, like a deployment, for example. We will see these concepts. We'll see them just very shortly. But I wanted to mention that Kubernetes is an open source technology. It was open sourced by Google in 2014, and it's part of the cloud native ecosystem. Kubernetes, it's a Greek word actually that means apparently helmsman or pilot. And the short version of it, of how we use it every day, is K8S, but it's still Kubernetes. So we still read it Kubernetes. Someone is asking where we can get the presentation, and everything about it is here. And the presentation PDF is actually under the folder presentation PDF. Cool. Why is Kubernetes so useful? It is useful because it helps us organize and manage a huge amount of containers that any enterprise level company has to manage on their daily business. It can scale the applications in busy times, as we said, by providing load balancing, by deploying the same container in multiple places, multiple times, even in different ports, as we saw before, that was possible. It also makes communication between various components easier. So you can also make multiple containers communicate with each other. It allows you to update your applications with zero downtime, and we will see this probably later in the examples, because there is a possibility of deploying a Kubernetes resource, an application, whatever, a node, a pod, a deployment. Basically, a Kubernetes deployment can be deployed with a rolling update. This is the name of the feature or the property, meaning that while one resource is scaling down or being killed, the other one will be immediately starting up. So you will have zero downtime for your applications. And it is also extremely useful because it has a very, very big and supportive community in the open source world and cloud native communities. There's even a cloud native conference happening every year, I think. And it would be nice to take a look at those if you're interested. When should you use Kubernetes? This is very important, and it's very difficult to answer because there are people who jump on the Kubernetes train just because it's a new cool technology, but not everybody really, really needs it. So it is useful for companies that have a huge amount of applications and services running, microservices, services, applications. And by this, I mean not just one or two applications that you can easily deploy in other ways, and you don't need such an infrastructure to run on the background of it, but it helps a lot if you have hundreds, thousands of applications and services that you need to manage. It can be an overkill in many situations, and there are good alternatives for smaller projects. For example, you can host your own server, you can host your own couple of servers, you can implement serverless functions, which are also pretty cool, like Google has their own Cloud Run, AWS has Lambda functions, and so on. In many different technologies, you can find this kind of support, and you don't always need to have to work with Kubernetes, basically, but once your company reaches those levels where this would be helpful, it would be really, really helpful. Core components of Kubernetes, nodes So a node is a worker machine. It can be physical or it can be virtual. A Kubernetes cluster will run on one or multiple nodes, depends on how it has been configured. A Kubernetes pod runs one or multiple containers. So one container will definitely run in a pod, but it can be that there are multiple containers in the same pod. So in order to run a container, you will need a pod that is up and running. But this pod can host multiple containers, basically. A deployment is a very, very important concept on Kubernetes. This is, again, an abstraction that is managing a set of pods and make sure that they are up and running. For example, when you say, in my cluster, I want to have at least 10 pods and I want them, so yeah, I want to have at least 10 pods or 10 nodes, or I want to have them up and running all the time. So I want to enable these rolling updates that I mentioned before. So you don't want any delays or any latency. You don't want to miss any data and stuff like that. This is possible for you. It is made possible by deployments. A service is also a very important concept in Kubernetes. This is an abstraction that exposes pods to other pods and services in the cluster, basically making it possible for these objects to communicate with each other. As we said, in a container always runs inside a pod, and the pod needs to communicate with other pods in order to enable any sort of communication between your containers, which in your case could be any application you have deployed. You don't want it to be like completely hidden from the world. You want it to be able to communicate with other applications, obviously. Namespace. This is a bit lighter. So in a sense, this is more like an organizational kind of concept. It isolates resources in a cluster. So you have a default namespace, and if you don't specify a namespace, you don't create one. All of the objects will be created on default namespace, but you don't want that. It makes sense from an organizational point of view to have specific namespaces for specific purposes on Kubernetes. So I don't know, you could, for example, have dev, staging, and prod namespaces, or you could have a namespace for a specific application. I don't know, we run an Airflow, for example, and we have a namespace for Airflow. We have a namespace for Airflow production and a namespace for Airflow testing, and a namespace for Airflow staging if you have a certain an intermediate application as well, and so on. And they are basically separate resources, so to say. So they are organized in namespaces. Cool. For this second demo, for us to be able to go through it, it would be nice if you could install Kind and if you could install kube control. So kubectl or kube control, I like to call it kube control. kubectl basically. So I will send you both links for them. So this is the Kind installation. But I mean, you can get these links also from the presentation, obviously. Still, I'm sending them in the chat. Okay. I will wait just like a couple of minutes to make sure that if somebody wants to, they can install them. And then I will continue running a bit of a couple of commands on Kubernetes so that we see what we're doing and why we're doing it and so on. Maybe less than a minute, just in case somebody wants to install Kind and install kube control. So the Kind command is going to help us, for example, to create a cluster and to basically to create resources. It does not require kube control to exist, but kube control is something we will need later because we want to be able to interact with the clusters that we create via Kind. Let's go back to home. Kind is a very cool tool that we use for running local Kubernetes clusters. So we create a cluster locally using Docker container nodes. and it was actually designed for testing Kubernetes itself, but since it was very useful, people started using it for local development or CI. And kube control is the tool for Kubernetes. So basically, this is how we access and interact with every kind of Kubernetes resource. Okay, I don't know if whoever needed to install them has installed them already, but I think we should kind of proceed so that we make it on time. I'm going to share my screen again. I mean, I'm sharing my screen, but I'm going to share my windows, my little command tool, if I can find it. Command line. Voilà. Okay, so I guess you see it. I'm sorry, this is also dark mode. Maybe it would be better if I run this on, I don't know if I can change this theme to brighter for, let's see if there is a settings for the one of you that asked me to do so. Theme. Okay. Light. This did not work, right? Let's close it and start it again. I'm just trying to make the theme light because there was someone of you asking if we can work on a light theme. But unfortunately, this is not working for me. Although I try to, it interesting, it only changes the top. Okay, that's not helpful. Then I think I'm going to use Visual Studio so that you have an easier time to see and follow. So everybody has an easier time to see and follow. What do we want to do? Just a second. The joys of running demos live. In the link that I shared with you, I tried Slavko, I tried to open a new one and it still did not work. It just changed the top of it. Thank you. In the link that I shared with you, where the presentation resources are, I will be now under Kubernetes demos, and I will be writing some commands from the kubernetes.bash file, which is not really a bash file. We don't execute it. I just wrote it like that. I'm going to run them one by one, okay? I will also make this a bit bigger so everyone can see properly. What I will do is I will try to create a cluster. And I will say I have autocomplete here, and I've done this many times before, but I will create the cluster called Kubernetes Playground. This should create a cluster for us in very shortly. Okay, excellent. What we can do now, even the command said it's super helpful. You can just run this command. So a kube control cluster info to get information for your cluster. I don't really need to specify the context, but you can. It doesn't hurt, obviously. And then it is telling us that there is a control plane, the Kubernetes control plane that is running at this URL. There's a core DNS running on this URL. And if you want to do anything else, you can get a log, for example, by dumping all of this information. We don't care about it. We don't want any more information. This is good for us. We just know that we have a cluster. So if I say kube control get clusters, okay, namespace, control. It does not have any. Okay, let me try and see. What did I do? Kube control. Get notes. We have this. We have the control plane. That is good. Okay. What do we want to do? We want to see if we have any pods. kube control get pods. No resources found in the default namespace. That's fine because we still have not created anything. We have not created any. Let's see if we have any namespaces. Only the default stuff, but nothing from our work. So this is whatever comes with Kubernetes installations. Okay, then let's let's do the following. Let's create our own namespace. Kube control create namespace hello Kubernetes, we will call it. And if I say now kube control get namespaces, as I said, this is just an organizational kind of thing. Hello Kubernetes from 6 seconds ago. Excellent. I will clear the terminal now because I like to have it nice and clean so that we don't need to see all of this stuff. And then what we will do is we will use the deployment file that I have already created before this presentation. So the one I wanted for a demo, it's called deployment.yaml. Kubernetes resources are always declared in YAML files. And in this case, a deployment will have the kind deployment. These are very, very, very static things. So this is a syntax. You go to the documentation for Kubernetes and see how deployment is specified. And then you even copy paste some sort of code that is existing there. And then modify to your needs. For example, in this case, the API version, I think I never changed this. This comes by default, whatever is the latest version for the Kubernetes API. And then the kind in this case for our file is deployment. Metadata says the name of this deployment should be hello Kubernetes. And the specification, I added here replicas 3 because later I want us to change this, but I can remove it for now. Selector match labels application is called hello Kubernetes because it's our application. The template will have metadata labels, hello Kubernetes, everything is the same for us. But these labels are very, very useful if you want to access different resources on Kubernetes via different labels. For now, for us, this does not matter so much. Our container will be hello Kubernetes, everything is the same, 88 is the default port, and everything else that I have here has been commented out. So basically, this is all that we have running in this deployment. If I try to create a deployment on Kubernetes in the namespace we just created, I just need to run Kubernetes kube control apply in the namespace hello Kubernetes, this file, deployment.yaml. Of course, it is complaining because I am not there. I am in Docker Workshop app, so I need to switch. Now I'm in I need to get into CD into Kubernetes demos. Okay, so here we need to go. And we are here. In Kubernetes demos, here I can run kube control, apply this YAML definition that I have created here so that we create a deployment for ourselves. And it says this deployment has now been created. That is pretty cool. What do we want to do now? We want to check or get deployments, basically. Get all of the deployments in the default namespace. There's nothing, right? Because we created it in the in our own namespace. Hello, I think we called it hello Kubernetes. Excellent. We have one deployment. We can also describe this. So Kubernetes kube control get deployment. Hello Kubernetes is the name. Option wide. So I see the YAML file. Okay, so I did something wrong here. I think you don't reference the name of the deployment exactly by name. You control get deployment. Hello Kubernetes, and I want to get option wide because I want to see all of it. Okay, cool. So Get deployment. I had forgotten to put the name. That's why the first time it errored. Option wide means with as many columns as you can give me. So with all of the information I can get. And I get that this is the name, it's ready, it is up to date, it's available, it's 71 seconds old. The container it's running is this one. The image it is running, it's this one, which is whatever we configured it to run. It could be the Nginx from before, for example, but we just chose some random image. And the application is Hello Kubernetes. That's pretty cool. Let's see if we have any pods for it. Yes, we have a running pod. The fun part with the running pods is that you can actually get into these pods. You can SSH into them and you can check them out. What I really love to use about this, about managing Kubernetes is a tool called K9S. It is also open source and for free. And of course, this tells me nothing now because I have a different context set up here, but normally I'm searching now for namespaces. Hello Kubernetes is our deployment. And if I go here, this is the pod. Exactly, this is the pod that you see. And if I on K9S is the tool, I will also write the name of it here. You can download it from the internet. It's an open source tool. If I, as you see here in the, I'm very sorry, this is also dark mode. I apparently use everything in dark mode. As you can check here, for example, you can, if you press S, you get the shell of this. So you can get into the shell of the pod. You can check everything you want to check in the pod. If you press D, which I will press right now, it describes the pod. And I will make this bigger. It says it's a Hello Kubernetes pod with this name. The node is this control plane node. The application is Hello Kubernetes, whatever we defined before. This is the image it's running on. This is the port it will be running on. What are there? All sorts of logs then, how this got set up and running. This is extremely helpful because sometimes these pods do not spin up correctly when you expect them to automatically happen. So to automatically get up and running. And then you just go here and you press S and you go inside, you're in the shell of this and you can do whatever you want. For example, I list what does this contain, for example. I can cat the Docker file just to see what content does it have. And I see that this image that we had has a Docker file of its own, and the Docker file has been defined like this. It comes from an Alpine image, so node image and so on. Things that we don't care about right now, but we would care if we are trying to debug. I pressed ESC, I think, no, exit, and then I'm out. Okay, K9S is also explained. What else can we do? I think that's pretty much it. Let's just go back to the presentation and see what are we doing. So we created the cluster already. Let me present. We executed some cluster info explain pod where this we didn't check out yet. It would be nice, whoever of you is actually running these commands live, it would be nice to check what your Kubernetes configuration by default when we set up Kubernetes and we installed it, installed kube control and set up all of our nodes and pods. We created a deployment. There is some configuration info stored in .kube.config, so .kube.config. If I run this, I will have a lot of stuff here, so I would rather not run it because I have configurations for my local Kubernetes as well. But if you run it yourselves, you should be able to see very few lines there that are, for example, having the context of your Kubernetes configuration and some, I mean, we can just Google a kubeconfig example file. Any example file. The context will be there, yeah. This is not what I wanted. I just wanted a YAML config file, but I guess you will see it locally from your execution, so that's fine anyway. Okay, get namespaces, get nodes, option wide. This just gives you more columns in the definition and so on. We deployed this deployment. So basically we said kube control apply this file, and the file is called deployment.yaml. Initially, we created the namespace, and then we created the deployment, and then we checked the deployments and the pods. We got into the pod, we checked the logs in the pod. And what we could also do is just run a port forward to 8080, and then maybe try to open this deployment for ourselves. So let's see, I need to get out of the full screen, open Visual Studio Code again, and run the port forward command. So kube control, opala. Port forward. And this is good. And let's see if we can open this. It seems like I can. So this is a port forward was there, namespace. The pod name is this, is exactly the same pod that we saw on K9S, or when we said get pods, for example. So it's this pod that is running 7KB, 7K48B, which is pretty cool. Yeah, I think I don't have a lot of time, so I could do this still. We can still create a secret if we want to, and we can apply it. Then you get a Kubernetes secret. You reference it in the deployment definition as and these things are all defined already in the deployment definition that you have. It's just commented out. What we could do, for example, is if I uncomment this, opala. This would mean that our deployment would have a limit for the resources to 250. I don't know if this is mega or 250 milli CPUs, 250 CPU limit. So this is a millicore. So 25% of a single CPU time, this would be it, and the memory would be 100 megabytes. And this is the limit, so that's as much as this container could ever, this deployment could ever get from my computer. And it can request, so when it starts, it can request 250 and 100. So this is a bit of a weird configuration, because in this case, I lost the chat with you. Somebody has two, okay, people have two questions. I'll just finish this thought and I will get back to the questions very soon. So I wanted to say that when you define a deployment, you are defining limits and requests. So you don't want the server or this deployment to get more than the limit. So it will be capped at that much resources, but you want it to have at least what you are requesting. In this case, if they are exactly the same, it doesn't make a lot of sense. So this is a default use case. You don't want to request exactly as much as you are limiting to, because it means there's no chance for growing at all. So basically, you give your deployment exactly the same amount of resources that it will always use. It is limited to exactly this one. It gets it from the beginning, and that's it. You could also make it start from, I don't know, 100 millicore CPUs and then 50 megabytes and let it grow to maximum 250 and 100. So that would mean that your deployment starts with a bit less resources, then you do a better resource management. And then if it needs to during running and people are requesting more from it and so on, then it could go up to these limits, but it won't extend more than that. Okay, this was very important, the resources and requests. Now I will get the two questions that I got. How do we decide whether to have one container per pod or multiple containers per pod? This is purely based on your needs. How many resources can you allow for yourself? How big are the machines that you have, where these pods are running on? So how powerful the hardware is, and it depends on business requirements. So you as a developer don't care. You have one application, you have one container for it, you want to deploy it, and that's it. If somebody else comes and has another container, and this is the cluster you have with 3 nodes, with 3 pods, whatever, it's not there is no way to decide it other than making the best use of the resources you have, basically, that is it. Bilal asks, as a senior data engineer, do you deploy applications yourself or there is a dedicated team for it? So in my personal case at the moment, whatever has to do with, for example, with my team, we are managing an Airflow installation that we also run on Kubernetes. We run the deployments ourselves, but that's only because the Airflow instance is dedicated to the data team in my team. In general, there is usually an infrastructure team that takes care of this, or a DevOps team. In my case, also because I like to work with these ones, I take care of that together with my team members, of course, regarding Airflow, because it's an instance we manage. Yeah. What else? I think we need to wrap up because there's another meeting starting soon. If there is any other question, we can take it. Otherwise, I think this was it. Okay, I think there are no more questions. Thank you very much for joining. I hope you have a great rest of the day and the week.